Okay, so we'll get started and see if anybody else pops on to join us. So let's get started with our PowerPoint that I have for us today. Okay, so this week we've been learning about what STEAM stands for. So Monday we learned about the S, which was what again?
Science.
Science. Yesterday we learned about the T, which was
Technology.
and today we're on the E, which stands for
Engineering.
Engineering. You guys are right. So the E in STEAM is for engineering. So if most of you remember last week, we focused our whole week on being an engineer. So you guys should be old pros at what engineering is. So let's get started. So what is engineering though? Engineering is when you use math and science to design things. And people who do engineering are called engineers. And they design and build complex products, machines, systems, and structures. So, with that being said, what kind of things do you remember us talking about that engineers make and build?
Cars, laptops, and all this stuff.
Like technology and everything.
Yep, and they don't just build technology too. They can also build bridges, and they can build that kind of stuff too. So first we're going to talk about a mechanical engineer. I picked 4 of the main engineers to talk about today. There are lots of different types of engineers, and like, you know how there are subspecies of animals where like you have a bear, but you don't just have a bear, you have black bear, brown bear, polar bear, that kind of stuff. So engineers are the same way. You have all these different engineers, and under each engineer, there is also a subspecies of other things that entail being under that engineer. So a mechanical engineer, they usually deal with anything that moves, from the components of a machine to the human body. So your typical mechanical engineer will deal with what, like you said, like making the cars and dealing with the laptops and all the mechanics that go into that type of stuff. Okay? And then after you have your mechanical engineer, you have your chemical engineer. Okay? And your chemical engineer is going to be used in designing equipment and systems and processes for like raw materials. They're also going to be dealing with the mixing, compounding, and processing of chemicals that make our valuable products that we need in the world today. And then you have your civil engineers, which they deal with design, construction, and maintenance of the physical and naturally built environment, including public works such as roads, bridges, canals, dams, airports, sewage systems, pipelines, structural components of buildings, and railways. So these guys have a big job because they have to make sure all the bridges they've made work well. So they have to be checking their bridges all the time. So you see them doing that a lot during the summer months, where you see all the bridge work that gets done or bridges getting fixed up and all that kind of stuff. But they're in charge of making sure our roads are good, our bridges are good, that all that stuff is always working the way it's supposed to work, so that we don't have any problems. And then you have your electrical engineers, and they deal with the technology of electricity. So they work on a wide range of components, devices, and systems, from the teeniest, tiniest of microchips to those huge, big generators that generate houses and big buildings and all that stuff that keep all of our lights on and going. Okay, so now we're going to talk about the engineering process, because there is an engineering process for how things get made. So what do you think the first step in the engineering process would be? Any guesses?
Get an idea.
What do you think it could be?
Like the idea to like make like a better version of the mechanical of like a mechanical arm for people who don't have an arm anymore.
Okay. So the first step of the engineering process is to define the problem. So like you said, it could be somebody doesn't have an arm, so that is a problem for them. That's the problem. Or another example would be the telephone. Years and years ago, when Alexander Graham Bell came up with the new way to communicate, that sending letters and all that just wasn't doing the trick anymore. They needed a faster way to communicate. You define your problem. You say what you need fixed, okay? So after you say what you need fixed, what do you think should be the next thing you'd have to do? After you define your problem, what would be the next step, you think?
You have to like ask a question and like how you're gonna solve the problem.
Okay. Okay, so the next step is you do your research. So you've asked your question. Now you're researching, how can I fix this? Has anybody else done anything to try and fix this? Has anybody else working on this? What ways do I think will work best to fix the said problem that I think there is in the world? So you've done your research. Now what do you think you have to do? Go ahead, Johnny.
Like make like an idea of like what it'll look like.
Okay, good job. So next you want to develop a possible solution. So if that is drawing it out or writing it down on paper, you're trying to develop what your possible solution could be. And then after you develop your possible solution, next you will design your solution. So you've developed your possible solution. Now you're designing it. Like I said, you're drawing it. You're seeing what it would look like on paper, and you may be drawing more than just like one design. You may be like, oh, I like this design, but oh, I also like this design, so I'll draw both of these designs and I'll see which one works better. So you've designed your solution. Then you have to build your prototype. So like I said, if you've designed multiple solutions, you could build multiple prototypes. Or you have those multiple solutions designed so you can build one prototype, and if that first prototype doesn't work, you still have other options. So you build your prototype. Then after you've built your prototype, you have to test it. You got to make sure it works, right? Make sure there's nothing wrong with it, that it works just the way you wanted it to work. And then after that, you evaluate your solutions. So what do you think you do if you've done all these steps, you get to the very end, you evaluate your solutions, and your prototype just didn't work? It completely was not what you thought it would be. What would you do?
Try again.
I'll do what
Just reset the steps.
I'll see if I can add more water to it to make it sturdier.
Yep. So you'd pretty much have to go back to the designing process of your solution. You would have to go back and just redesign and rework it and keep going until you get the right thing. So engineers have to do a lot of work. They have to do a lot of testing, and if it doesn't work, it's just a trying process. You try. If you fail, you try again. You don't give up. You just keep going until you get everything you get it the way you want it to go. So next, I have a few videos I want to share with you. They are a couple of videos from a show called Lego Masters, and they had to build bridges out of Legos that could hold a lot of weight. So I'm going to show you 2 videos. The first one shows them putting the weights on a little bit better, and then the second one shows which bridges were able to hold the most weight. Okay? So let me share my screen with you guys, and make sure if you cannot see the video, you guys tell me so I can fix it, so you guys are able to see what I see. Okay, this is the first video. Let's let it get big first. Come on. Okay, so this is the video of, and you'll watch them as they're putting the weights onto their bridge, and listen to how much weight they put on just this one bridge alone until it breaks. Okay,
though, I'm like, how much is it gonna take? 325?
see, they're at 325 pounds.
Oh my god!
I tell you, you can't get this kind of excitement on The Masked Singer.
Oh,
How's it closing?
it's 315. It's a lot of weight. This is insane right now.
Crazy.
What'd you say?
Oscar is frozen, so we can't really see them moving.
Oh, okay.
Now it's 365. Let it go gentle.
365.
We're running out of weight.
Look at how they get all excited every time they put more weight on it. Scared it's gonna break.
As you can see, we were not expecting any of these bridges to hold so much weight. Okay, what do we got?
Okay.
We had to get weights from the camera department. How unprofessional do we look as a television show right now? Not only are we going to find out who wins the golden brick, we're also going to find out who's getting fired from the show.
So this is gonna be 400 if we get this one. Okay. Look out, look out.
That is
So that's
400 pounds.
400 pounds are on that
This is for
bridge right now.
445, dead center.
So that bridge, where it stopped, they had 400 pounds on that bridge. Do you think Legos could hold that much weight if you built them just right? Isn't that crazy, guys? And then, okay, now the next video is going to show you how much weight the 2 best bridges that were built, how much weight those 2 held, okay? So give me 1 second, and I'll get that one pulled up for you. Okay, so here is the other one that shows how much weight the 2 best bridges that they built on this show could hold. Okay?
Our Super Bridge Challenge featured 2 teams, Tyler and Amy and Mark and Boone, that did really, really well, and both bridges withstood 1,000 pounds.
Did you hear that? How much weight did these bridges withhold? How much weight did these Lego bridges hold? Did you hear that number?
1,000 pounds.
1,000 pounds. These Lego bridges held 1,000 pounds.
1,000 pounds! Honestly, it's just too dangerous for us to put any more weight on that. You've broken our show. This is absolutely insane. 2 bridges, 1,000 pounds. This is crazy.
We are tied.
So these guys were able to build 2 bridges that were able to hold 1,000 pounds. And because of the show, they thought it was too dangerous to put any more weight on. So they probably could have held more than just 1,000 pounds. Do you guys think you could do that with Legos? Build bridges that could hold that much weight? No? No, not at all?
It will probably was 1 pound.
It could probably hold 1 pound. Yeah, so that's being an engineer, because if you saw the first video where their bridge only held about 400 pounds. So see, that's how they built their bridge a certain way, and it only held about 400 pounds. But these other 2, they built their bridges so strong and put the Legos just right that their bridges were able to hold up to 1,000 pounds. So that is pretty impressive, I would say. I'd be pretty impressed if I could build a Lego bridge that would hold 1,000 pounds. Okay, so like I said, we've discussed engineering before. So what other things do you guys remember about engineering or being an engineer? Did you guys try all of the stuff that we did last week? Any of the projects? Did they all turn out? Did you have to try something different? Anybody gonna talk?
No.
Okay, well, I know for today, you guys had a challenge, kind of. You were given in your kits, I believe, newspaper and masking tape. And you guys are supposed to see who can build the strongest or tallest structure. It was your choice to build the strongest or the tallest structure. And then make sure you took pictures and that you post it on the webpage for everybody to be able to see what you created. Excuse me. But there is a lot to being an engineer. There's lots of jobs to do, lots of things that help keep this world definitely running. So it is definitely a very interesting job. So let's see. Are you guys building a structure over there? Yeah. Okay. Does anybody else think they're gonna try and build a structure today, or build something and see if you can make it the tallest or the strongest?
Me and my brother might.
You might. Well, make sure if you do, you take pictures and you send them to our website so that we can put them up for you guys. Then you get chances to win our fun prizes, like gift cards for niece.
Type of fun prize. Wait, what?
I know if you participate, if you fill out our surveys, and if you send us your pictures and the stuff you're doing at home, and they get added to our site, you are able to win different kinds of gift cards. There we go. I couldn't think of my words that I was looking for. I know some people have won gift cards to Zestos and lots of other. What?
I ain't going to Zestos right now.
Oh, you want a gift card to Walmart? But yeah, you guys are able to get prizes for participating. And we would really like to see you guys doing these projects at home and sending them to us, and all of that fun stuff. So like I said, this week, though, we're focusing on full steam ahead. So we've focused on the S, which was what again, guys?
Science.
Science. We focused on the T, that was
Technology.
Technology.
Today we focused on
Engineering.
And tomorrow will be the A. Don't spoil it, because that'll be the first question I ask you tomorrow is, what does the A in STEAM stand for? So don't spoil it today. If you know it, great. If you don't, maybe you should do some research tonight and figure it out. But tomorrow we'll be talking about the A in engineering. And be prepared to discuss all of that fun stuff that comes with the next letter in our fun word of STEAM. I hope you guys have a great rest of your afternoon. Get outside. It's beautiful outside. Enjoy some lovely weather. And I will see you all tomorrow for another lesson. Have a great afternoon, guys.
Bye. Bye, Elizabeth.
Bye, Bernice.
Bye.
Bye. Enjoy making your structure. Make sure you send us pictures of what it looks like, okay?
Bye.
Bye.